Okay, so we have worked with this matrix A, this 3 by 3 matrix A, where again the first column is 3, 1, 2, and the second column is minus 1, 2, 0, and the third column is 2, 0, 1. And we showed that we can take the determinant of this matrix by working across the top row and taking A11 times the determinant of submatrix A11 minus A12 times the determinant of submatrix A12, and now plus A13 times the determinant of submatrix A13. And after those calculations, we found out that the determinant of this matrix was minus 1. There was nothing particularly special about going across the top row. We could have calculated this determinant in a similar fashion, working across the second row of this matrix. And the way that would work would be as follows. So we're going to start first with entry A21. So second row, first column. And we cross off those entries, and then we take a look at the corresponding submatrix that we get. And then we would work our way across to the next entry, A22. We would cross off all of the entries in the same row and column as A22, and then take the determinant of that submatrix A22. And then we can take this last entry, A23. We eliminate all of the entries in the same row and same column as that, and we're going to use submatrix A23 and think about the determinant of that matrix. And we're going to combine this information in the following way. We're going to put a negative sign in front of the A21 term and then multiply that by the determinant of A21. And now we're going to add A22, lowercase a22, times the determinant of that submatrix. And then we're going to subtract the A23 entry times the determinant of that submatrix. And so now let's plug in our information. So A21, remember that was this entry 1. And we have this negative sign that is in front of it. And now we're going to add to it A22, which is the entry right here, 2, times the determinant of submatrix capital A22. And then we are going to subtract from that entry A23, which is 0, times the determinant of submatrix A23. And because A23 entry is 0, it actually doesn't even matter what the submatrix is or what the determinant of that submatrix is, because we're going to multiply it by 0 anyway. And now we are left with just 2 determinants that we need to calculate, because again, this third one doesn't really matter because we had a 0 in this entry over here. And wrapping this calculation up, we see that matrix A21, its determinant is negative 1. That's why we've got a minus 1 over here. A22, its determinant is 3 minus 4 is minus 1. And then we have this 0 term over here because we have a 0 times whatever the determinant of this matrix is. So this gives me a positive 1 minus 2 for a negative 1. So we get the same answer as we did in going across the first row as we do if we go across the second row. There's one big difference in that when we went across the first row, we had a positive piece, a negative, or subtracted this piece, and then we added this piece over here. When we go across row 2, we started with a negative, then we added this piece on, and then we subtracted this piece on. So it's the same general idea, but we're using different signs along the way. And you might be thinking, well, would it have been possible instead to go across the third row of this matrix? And we could. So we could instead have gone across row 3. So I would take the A31 entry, which is 2 in this case, and then looked at the corresponding submatrix A31, which would have a first column of 1, 2, minus 1, 2, excuse me, and the second column would be the 2 and the 0 that's left over. And then we would subtract A32. Now A32 is a 0 over here. So it actually doesn't even matter, but I would take this 0 and multiply it by the determinant of submatrix A32. And again, because A32 is 0, it doesn't even matter what I get over here. 0 times whatever this is going to be 0. And then I have my A33 term, which in this case is 1. And then we would multiply that by the determinant of the submatrix A33, which would be 3, 1 in the first column, minus 1, 2 in the second column. And now I've got my 2 times the determinant of this matrix is minus 4, minus 0, plus 1 times the determinant of this matrix, which is 6, plus 1, 7. And now we've got a minus 8 plus a positive 7, and that gives me a minus 1. So all three of these ways are giving us the same value. And what's significant about these formulas, again, is that they correspond to conditions such that if the determinant of A is not 0, this matrix is going to be invertible. If this quantity that we defined as the determinant is 0, then this matrix wouldn't be invertible. And depending on which row we go across, row 1, row 2, or row 3, we do need to adjust signs accordingly. So let's kind of summarize how that goes on the next slide. So let's summarize some key observations from this example. So we were calculating the determinant of the same matrix, this 3 by 3 matrix A, where we have got 3, 1, 2 in the first column, minus 1, 2, 0 in column 2, 2, 0, 1 in column 3. And we've seen that we can go across the top row, and that would give us this formula over here. We could go across row 2, which would give me the second formula that we have down below. Or we can go across row 3, and that corresponds to the formula that we see for the third bullet down below. And what is important to note here is that it makes sense to choose rows that have zeros in them as opposed to a row that has all non-zero terms. So going across row 2 or row 3, we actually had one less determinant to calculate. Since, for example, in row 2, entry A23 was 0, so we didn't need to worry about the determinant of submatrix A23. And for row 3, because entry A32 was 0, we don't care what the determinant of matrix A, submatrix A32 is. So if we choose to go across rows that have zeros in them, that's going to require less calculations. And because we have different ways of doing it, we can choose whichever row that we want. This means there may be faster ways of doing this, and there may be slower ways of doing that. The second observation that we want to keep in mind is that we do have some weird pattern that is going on with the signs about how are we adding or subtracting different products of entries times the determinant of their submatrix. And so what we can see here is that when the sum of the subscripts, so the ith row indicator and the jth column indicator, when those add up to an even number where we have a plus sign in front of that term, when the row and the column add up to an odd number, such as in this case, the 1 plus 2 gives us a 3, we put a negative sign there. So to determine whether or not we put a plus or a negative sign in front of that term depends on the sum of I and j. If the sum of I and j is even, then it's a plus. So here we have a plus. 1 plus 3 is even, we have a plus. 2 plus 2 is even, so we have a plus. 3 plus 1, even, we have a plus. 3 plus 3 is even, so we have a plus. For any of the terms where the subscripts add up to something odd, such as A12 or A21 or A32 or A23, right? All of these entries we subtract because the sum of I and j gives us an odd value.